Okay, talk me through your working.
M equals -1 minus 2 over -10.
Yeah, so -1 taking 2.
Over -10 minus 5 equals 3 over 5.
-3 over -5, which is absolutely right, cancels down to 3 over 5. Well done, okay. That's your gradient, it's 3/5. That. Okay, then what?
Y equals mx plus c.
Good, well done.
And 2 equals 3 over 5 multiplied by -5 plus
Okay.
c.
So you're using point A, right?
Yeah.
Okay, so you're using this equation and x equals -5 and y equals 2. So just read out that last line which you wrote out again. So 2 equals
3 over 5
Yep.
multiplied by -5 plus
Yep.
c.
Perfect, well done. Okay, so what do you get? How do you solve this equation?
2 equals -3 plus c.
Perfect, well done, because of course the divide by 5 and times by 5 cancel. Good.
2 plus 3 equals c. Then c equals 5.
Well done. So what did you get as your final equation of the line?
Y equals 3 over 5x plus 5.
Excellent. 3 over 5x plus 5. Well done. Okay. Now that's fine. Okay. I will just give you another version of the way to solve this just for completeness, and then we'll take a break. So you notice that we're kind of relying on this formula here, the y equals mx plus c. Okay. There's a couple of different ways that you can be asked to leave your answer. Okay. So one way is like this. If it doesn't say anything, it just says find the equation of the line passing through these 2 points. It means you can just leave it like that. That's fine. Okay. But you see here, it's kind of a fraction. Okay. So another way that we can actually leave our line. So let me write it in red. So leave your answer in the form ax. So let me write that down properly. Ax plus by plus c equals 0, where a, b and c are integers. Okay, so where a, b and c are integers. So this is asking for what form you want to leave the final answer in. This form, the y equals mx plus c, is often called either gradient intercept form, so gradient intercept form, or slope intercept form, okay, because obviously you can see the gradient, you can see the slope really easily. Again, the y-intercept. Okay. This form, so ax plus by plus c, where a, b and c are integers, is called general form. Okay. It looks slightly easier. It's kind of following on the idea of our quadratic. Because if you want to solve a quadratic, you always set it equal to 0. Okay. And you try and make sure that all the coefficients, all the numbers which are multiplying each term, are all integers, are all nice numbers. Okay. So if I take this answer here, the answer you told me, y equals 3/5 of x plus 5, and if I want to leave it in this form here, would you notice first of all, this is equal to 0. So I guess first of all, let's just make this thing equal to 0. Okay? So I guess I can do that just by taking away y from both sides. Okay? So I end up with 3/5 x take away y plus 5 equals 0. Okay, so we're one step closer to this form, but it's not quite in this form yet, because it's asking for a, b and c to be an integer. What does an integer mean? It means a whole number. Okay? So for example, 3/5 is not an integer because it's a fraction. 1 is an integer and 5 is an integer. Okay? So an integer just means a whole number. So how can I make every single number, every single coefficient, an integer? Could divide by 3 over 5, or more simply, just divide everything by 5. Because you saw down here that when we had 3/5 and we times it by 5, the divide by 5 times by 5, they cancel. Okay? So what I'm going to do is go through and multiply every single term by 5. Okay? So what's 3/5 times 5?
3.
Good. So this is going to be 3x. What's -1 times 5?
-1 over 5.
Good, -5y. That makes sense?
Yeah.
because you're timesing by 5. So you've got negative 1 times 5, that's negative 5. What about 5 times 5?
1.
Sure. Isn't it just plus 25?
Oh, multiply.
Yeah, multiply, not divide.
Sorry.
Yeah, that's alright, don't worry. So 5 times 5, what's 0 times 5?
0.
Good. That there would be in that form. Is that okay? Right? So if it says in the answer, give your answer in this form, that's one way that you can do it. Okay?
What is the form?
So this form, can you read it, or do you want me to write it out a little bit bigger?
Yeah.
Okay, so the form is ax plus by plus c equals 0, where a, b, and c are integers. So integers in this case just means whole number. Let me write that out a little bit clearer. So an integer just simply means a whole number. Right. So I'll just look at a very similar kind of question to what we were just looking at, and I'll show you a slightly different way of solving it, and then you can make your decision over which form you prefer to solve it in. Okay? So you could absolutely solve this in exactly the same way that we just did together, so the y equals mx plus c, but I will show you an alternative method. Okay? So first things first, let's go ahead and find our gradient. So can you calculate your gradient at the same time as I do it? Okay? So to find the gradient of this line, you're going to have to do negative 2, take away 8, divided by 3, take away 6. So that's going to be negative 10, 3 take away 6 is negative 3, so that's going to be 10 thirds. Okay, so you're happy you get 10 thirds. Okay. Now, because I know, in this case, that I'm looking for my answer to be left in general form, so the ax plus by plus c equals 0, where a, b, and c are just integers, they're just integer coefficients. And because I see that my gradient is non-integer, okay, it might be easier in this case to solve it in a slightly different way, okay, because I know that my answer is looking for integer coefficients, and I can see my gradient is already going to start screwing things up, so it might make sense to solve it in a slightly different way. So instead of going y equals mx plus c, let's use an alternative equation of the line. Just remind me, what is the general form, what is the general equation for gradient?
y2 minus y1 over x2 minus x1.
Perfect. Okay, so that's the general equation of the gradient. Now in this case, because I'm going to be solving it for a general x and a general y, so I want my equation of the line to look something like this, where x and y is just some general set of coordinates that lie on the line. Okay? So in this case, I'm actually only going to be interested in like x1 and y1, and x2 and y2 are just going to be general coordinates on the line. So what I mean by that is I'm just going to write it like this instead. Okay, so instead of having two sets of points, I'm going to say x and y is just any general pair of coordinates that I know lie on the line, and x1 and y1 are specific set of coordinates that lie on the line. Namely, either that point or that point. So if I rearrange this then, make it non-fraction, would you be happy I just multiplied both sides by that denominator? So therefore I'm going to be left with y take away y1 is going to be equal to m times by x minus x1. That make sense? Literally all I've done there is just multiplied through by that denominator. Now, the reason why this is handy is because now this is an alternative formula I can use down here. So instead of going for y equals mx plus c, I can just use this version of the formula instead, because it's exactly the same thing. It still follows the rule of a straight line. I've still got y's and x's, and I've still got my gradient, and the constant should just be, the constant from y1 and x1 should just be the y-intercept.
Is it 0 in the beginning?
Well, this thing here,
Yeah.
sorry, that is my implies, so you don't need to worry about that, that's just sort of notation. Basically says, because this is true, this must also be true as well, but it's fine just to ignore it. So therefore, what I can say is instead of using this version of the line, I can use this version of the line instead.
Why would put y minus y1?
Y minus y1.
No, y2 minus y1.
Okay, so why is it not y2 take away y1? So why have I got rid of the y2 and the x2 and just called it y and x? Is that what you're asking? Yeah. The reason why is because look at this equation of the line up here. Okay? This equation of the line only has x and y in. That's basically saying if I want to link together any point that lies on this line, I just stick an x coordinate in and find the corresponding y. So it means that because I know what my equation of the line should look like, it should have a y and it should have an x in, then I'm just going to leave y and x here, and I'm just going to say the values that I'm going to stick in are going to be y1 and x1. Okay, it's just a bit of a notation thing. Okay, so don't get worried about it too much. So what I can say then is because in this case I'm looking for my answer to be left in this form here, the ax plus by plus c equals 0 where a, b and c are integers, then what I can say is because I know this is not an integer, I'm going to go for this version of the formula for the straight line instead. Okay? If it was an integer, y equals mx plus c will probably just be as quick. Okay? But because I'm looking for integers, I'm probably going to go for this one instead. So let's go y minus y1 equals m times x minus x1 like so. And then same thing as before, I still need a general x and a general, or I need a set of x and y coordinates which lie on the line. So I'm just going to use a, but I can equally use b. So 6 and 8. That makes sense? The same as before. Okay? It's just I'm substituting y equals m plus c with this new version of the formula we've just found. Okay? So now what I need to do is just stick it in here and see what we get. Okay? So let's have a look. Well, y is just general. y1 in this case is 8. Okay, so that's going to be y1 and that's going to be x1. Okay? So, okay, y1 in this case is 8. That's going to be equal to m, which in this case is 10/3, times by x, which is general, take away x1, which is 6. Okay? Now you might be sitting there thinking, how on earth is this any better than this? Okay? How is this any better? This works, stick with that, but why are we looking for a new version? This is the reason why. Because if you use this version of the formula, it will nearly always be quicker to get to this. Okay? So if you use this version of the formula you need to get here, it's going to be quicker, okay, than just using y equals mx plus c. So it's just an alternative method. Okay? So what I'm going to do, because now I'm looking for integers, I'm going to multiply everything by 3. That's the non-integer bit in here. So if I multiply everything by 3, on the left-hand side I'm going to get 3y, take away 24, because I've multiplied that by 3. On the right-hand side, well, I've got 10/3 times by something, that's just going to be 10 times that thing. Alright? So I've literally just multiplied both sides of the equation by 3. And now all I need to do is just expand that right-hand side out. So 3y, take away 24, equals 10x minus 60. And then all that's left to do is make it all equal to 0. So I've got integers, left, right, and centre. So now all I need to do is make it equal to 0. So I'll end up with 10x minus 3y, then plus 24, take away 60, that's going to be negative, what's that going to be? Negative 36 equals 0. So you look at that and you think, well, I could have really successfully answered this question and used y equals mx plus c here instead. Yes, you could. We did that. We did 2 examples of that, okay? But what I'm saying is, it's always good to have extra options up your sleeve. I would argue that this version of the formula is quicker if you need to leave your answer like that, okay? If you don't need to leave your answer like that, then absolutely just go for y equals mx plus c. So always look at what version your answer is looking for. So if it's the general form, ax plus by plus c equals 0, where a, b and c are integers, absolutely go for this version of the formula, okay? If it's not, if it's just simply find the equation of the line passing through these 2 points and nothing else, means you can leave it in y equals mx plus c, then use y equals mx plus c. Okay, so really it's up to you which version of the formula you want to use. I'm just giving you the tools which you can choose from. Is that okay?